Alright, this is an example of how to take a graph of a function and find its equation. So here we have a graph of a sine and or a cosine graph. And each one of these blocks going to the right is pi over 12. So two of them would be pi over 6, three of them would be pi over 4, and so forth and so on. So here I have to distinguish whether we're talking about a sine graph or a cosine graph. And there's three pieces you need to know. The amplitude of the graph, the period of the graph, and the phase shift of the graph, which is related to B and C. So when we look at this picture, to determine these things, let me get a little line going on here. I'll use that one. One of the things you have to notice is the graph upside down or is it right side up? So to determine if it's upside down or right side up, you try to find out where a cosine would normally go. Generally it would start at +1 and then start its way down. And I can't go back far enough to see what's going on back there. So the next hump is down here. So this is going to determine what happened to the A. So the A is related to the depth of or the height of the function. So if we were looking positively, the height of the function from the center line to the top is 1.5. So I could say A is 1.5. The problem with that is the first hump we're looking at is going down 1.5. So from that information, we can pretty much say that A is equal to -1.5. The amplitude of the function is 1.5, but to get the graph to start low and then go high, it has to be negative. All right, so that gives us A. That's usually one of the easier things to find. But once you determine that this point down here is the starting point of cosine, all the other information kind of comes from that. All right, so let's look at another piece of information. If we're starting at this lower hump down here, and we're looking for one period of the graph, well, that would be going from bottom hump to bottom hump. So this distance here would be the period of the graph. It started low, it went high, and it came back to exactly where it started at low. So this would be one period of the graph. So to determine the one period, what's the length according to this graph, we just kind of have to count over how many spaces. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is a period of 8 pi over 12, because each one of those markings is pi over 12. So this reduces to, let's see, 4 goes into both of them, 2 pi over 3. So the period of this function is 2 pi over 3. All right, so far we have the A and we have a period. One of the last things we need to look for is the phase shift or the translation. So let's try purple. So the translation to get to this hump, even though it's been flipped upside down, is the distance between where the hump starts and where it should have started. So we're talking about that distance there. That would be the phase shift. So we can say the translation, the phase shift, I'll put phase, is a positive. It got moved in the right direction. It's a positive 2 pi over 12, also known as pi over 6. All right, so this graph has a amplitude of -1.5. It has a period of 2 pi over 3, and it has a phase shift of specifically positive pi over 6 to the right. All right. Now phase shifts could go to the left too, and then of course it would be negative. All right, so using the bottom two, we should be able to find out what B and C are equal to. All right, so let's start off. I usually don't try to memorize anything. I always set it up the same way every time. So bx plus c is equal to 2 pi. This is how we find what the B and the C do to our graph to change the period and the translation. Here we know what they are, so what we're looking for is B and C. So when you solve for x, you're going to get the translation of negative C over B, oops, and then you're going to get the period of 2 pi over B. So all we have to do is set things right. So here is the period, and here is the phase. So that's just a little bit of algebra. Let's start with the period. We know that 2 pi over b, the period, has to equal, 2 pi over b has to equal 2 pi over 3. Oh, that's pretty straightforward. If this is the case, I mean, the 2 pi's are both on the top, b is going to equal 3, but let's go algebraically and find out why. So if we cross multiply, we're going to get 2 pi over 2 pi times b is equal to 6 pi. And when you divide both sides by 2 pi, you're going to get b is equal to 3. Okay, usually it's not that easy. All right, next up is the c. So we know that negative c over b, the transformation or the translation or the phase shift, has to equal pi over 6. Usually before I start plugging in for b and c, I solve for c first. So c is going to equal negative pi over 6 times b when you multiply both sides by b. Now I know what b is equal to. B is equal to 3. So c is going to equal negative 3 pi over 6, also known as negative pi over 2. All right. So now I can fill in all of the missing information to my function. My function is going to be a is negative 1.5. This is a cosine graph. B is equal to 3. X, t, theta, whatever variable is going to be there. And then c is just minus pi over 2. And there is the function of a cosine that has this specific graph. So you have to look at the graph correctly, but usually with cosine you go hump to hump. For sine you go from x-intercept to x-intercept. Don't go to the first one though, go to the second x-intercept. So the period would be that distance. Well, hope that helps.